REACH is a multi-institutional research project to improve climate change adaptation and mitigation strategies for cereal-based cropping systems in the inland Pacific Northwest. One objective of REACH is to understand how different weather conditions and different management practices impact greenhouse gas emissions in cereal crops such as wheat or barley. By measuring greenhouse gas exchanges in different field conditions, researchers can better understand these differences, and they can collect baseline data that can be used to analyze how different management practices might impact future greenhouse gas emissions. The most direct and accurate way to measure carbon uptake and nitrogen loss between the atmosphere and agricultural land at the field level is using the eddy covariance flux method. This diagram illustrates how updrafts and downdrafts at the surface of the Earth are the result of turbulent eddies in the air. Using eddy covariance flux towers to measure the changing speeds of updrafts and downdrafts, scientists can calculate the net release and uptake of gases such as CO2. On the eddy flux tower, the sonic anemometer measures three-dimensional wind speeds by shooting ultrasonic sound waves back and forth, while an infrared gas analyzer uses an infrared light source to measure carbon dioxide and water vapor concentrations. Each of these instruments takes 10 measurements per second. In addition to measuring greenhouse gases, the eddy flux tower collects other meteorological data. A probe measures temperature and relative humidity. Sensors measure incoming solar radiation and outgoing long-wave radiation emitted from the Earth. A photosynthetically active radiation, or PAR, sensor measures how much light is available to plants for photosynthesis. A cup and vane anemometer measures two-dimensional wind direction and wind speed. A tipping bucket rain gauge measures precipitation, and buried in the ground at various depths are probes that measure soil temperature and moisture. The whole system is powered by a battery bank charged by solar panels. The instrumentation also includes GPS as well as a cellular modem which transfers data back to the WSU Atmospheric Research Lab on a daily basis. Flux tower measurements collected over the course of a year result in an annual budget of CO2 losses and gains from the environment. And by placing eddy flux towers at sites across the study region, scientists hope to better understand how meteorology and management practices impact greenhouse gas emissions.